at those discussion questions you just went through. So 10.20 says, you are standing at the center of a large horizontal turntable in a carnival funhouse. The turntable is set rotating on frictionless bearings. Okay, so the fact that there's frictionless bearing, there's no net torque, meaning your angular momentum is constant in this situation. As you walk toward the edge of the turntable, so you are increasing the radius of your mass. That means you're increasing the moment of inertia you are contributing to this situation. What happens to the combined angular momentum of you and the turntable, and what happens to the rotational speed? So the angular momentum is constant because there was no net torque, but as you walk out, your I value gets larger. That means your omega value gets smaller because I times omega is L. And so if you have a constant L, the only way for your I to get bigger is if your omega gets smaller. And this is what you experienced when you did your summer homework of walking on the merry-go-round. Question 27 asks about a helicopter. So why does it have that back little tail rotor? So the idea is that as the top rotor spins, it runs into some resistance from the wind. That's good because it wants to push the wind down, or the air, and so that causes a torque to be put back on that rotor, opposite and equal forces, opposite and equal torques kind of thing, and so it causes the helicopter to get some turning. And so the idea is we get a torque from the upper blade that wants to rotate the helicopter one way, so that back rotor is designed to kind of counteract that. And so it will speed up or slow down depending on how much kind of resistive torque it's getting from that air. Now, what's the idea with two rotors? One spinning one way, one spinning the other way. The idea is those two rotors will balance each other's torque, and so you won't need that rear rotor. Think about action movies, if you will. Like sometimes they'll hit that rear rotor, and what happens to that helicopter? It usually does some sort of spin into a crash, and that's because it loses that balancing torque. Right. And the last one says, a bullet spins on its axis as it emerges from a rifle. What is the benefit to this? Think about the same thing for throwing a spiral on a football or doing any type of thing where you give something spin. The idea of giving it spin is you're giving it angular momentum. And so if I give it angular momentum in a given direction, so for instance, here's our bullet coming out, it has angular momentum in this direction as it rotates. And in order to change that angular momentum, in order to point my bullet in a different direction, it's going to require some torque applied over a period of time. And so it maintains that orientation. Think about the example we're going to do, well, we're going to do it tomorrow in a later video, I guess, where we take the wheel and we'll spin the wheel, but you'll see that on a different one. Great video, Foster.